lastly, we have the right on section, and they give you the problem 7x is equal to 84. Now, I know you're going to want to solve this, but it says write a story or a situation to fit this equation. Now, if we think the definition of x is called a variable, right? So it has to stand for something. So we're looking for a number. And this number could show something like cost per, like if x was 1, then 7 per 1. And then if you had x was 2, then 7 per, or 2 times 7, 14. It's different intervals. It's kind of hard to see. But if you think you plug in different numbers for x, then you're going to get multiples of 7 for each. So if you think about a problem, I mean just anything, I would right off the bat think about prices. If you think like you're going to a fair or something, 7 could represent your cost because it's a fixed amount. It does not change. A variable can change. So let's say some kid is wanting to go to the fair and he wants to see how many tickets he can buy. And think of 7 as $7 per ticket. So that basically means per person it's $7, right? So x can be how many people can go, right? And so, of course, to solve this, you divide 7 into 84, and I mean you could figure out how many people could go to the x would represent people going. So, I mean, just stuff like that. You can do stuff with like seating arrangements. Like if you have, if somebody says you have a total of 84 chairs and you've already lined up 7 in a column, how many rows can you make? Or like how many chairs would be in a row? Okay, so you just divide into there and you'd say, what is that? 12 chairs in a row. Just anything like that. They just want you to come up with a story to think about what that variable means and what that fixed amount means, which is 7. Next we go on to the equations. Do these without a calculator, please. 15 times 72. I'll just go through it just in case you're having a brain fart or something. So 10, 2 plus 1, 30, 0, 35, 7 plus 3, 1050, 0, 8, 0, 1. 1080, is that right? And that is right. 1080. That's your answer. As you progress doing this without a calculator, you will get faster, don't worry. It just helps with your logical thinking to do that. Next one, solve for b. You gotta use PEMDAS, that's what I call it. Parentheses, exponents, multiplication, division, added, subtraction. And so we go for the multiplication first because that's the first thing we see. 4 times 2 is 8. And then we go straight across because it's all addition and subtraction. It doesn't matter. Subtraction doesn't come before addition or anything like that. So 6 minus b plus 8 is equal to 12. So we can add the 6 and the 8 to make 14. Plus we have a negative b. Make sure you see that sign in front of that b, that negative b. If you have 6 minus b, remember your rules with changing signs. You can change the sign just like that. That's why you can do this. If you think it's 6, a positive 6, I mean this is understood right here. A positive 6 plus a negative b. That's the same thing as 6 minus b, right? So that's why this property is true. You can flip both signs and it'll be the exact same thing. So we end up with negative b plus 14 is equal to 12. So 12 minus 14 is negative 2. And then you divide by negative 1 and you get 2. B is equal to 2. That's your answer. Okay, next one. 9/16 times 6 times, and 2/3. You want to keep the same form of a fraction in this equation. It's just going to be easier if you convert the mixed numbers to improper. Or like if you wanted to make the mixed numbers and multiply them, that'd be fine too. But I would prefer you to use improper fractions. So you have 9/16 times, remember how to convert mixed numbers to improper fractions. 6 times 3 is 18 plus 2 is 20 over 3. And multiplying fractions, you just multiply the numerator and the denominator across. Let's see, adding, you have to have a common denominator. You just add the top, you keep the denominator the same. Subtracting, the same thing goes. And so here you have 20 times 9, which is going to be 1800. No, just 180. That was dumb. Okay, 180 over 16 times 3 is 58. 58, right? I don't know what I'm doing. Crap. 58. So we can reduce this fraction. First, I'm not going to try and think of, let's see, 58 divided by 4. So go ahead and divide by 2. Get 90 over 29. 29. Is that all you can do with it? Yeah, that's all you can do with it. That can be your answer. You convert it back to a mixed number, and the way you do that is you think, how many times can 29 go into 90 without going over? Well, let's see, 29, 58, 92, so only 2 times, wait, 3 times, 29, 87, yeah, it doesn't go over, so 3 times, and you have 3 left over. This is 3 left of 90, so you have 3 over your denominator here, 29. I think that's right. No, it's not. Dang it. How's that not right? So it's 3 3/4. Did I write the equation wrong? 9/16 times 6 2/3. 18 plus 2, 20 over 3. 20 times 9, 0, 8, 19. Oh, that's 190, isn't it? That's 190. No, that can't be. What am I thinking? I'm having a major brain fart. It's been a long day. Yeah, it's still 180. That's what I thought. 16 times 3. 18, 4, 5, 58. You reduce that. Did I reduce that wrong? Is that what it is? 40, 58, 29. What? 90. You can't divide anything into 29, it's a problem number. Crap. What in the world? Let me punch this in my calculator real quick. That can't be right. What are they talking about? 6 times 3 is 18. Plus 2. It's 20 over 3. It's 180 over 58. 16 times 3. What? Oh, dang. I made a dumb mistake. I added the 3 and 1 right here, so that should be 48. That was dumb. 24.